Okay, sir.
So, good afternoon, everyone. I welcome you all for this one-day workshop on prototype and process design and development. This workshop is organized under the Institute Innovation Council of Panimalar Institute of Technology. I thank Mr. Amos David for readily accepting to give a seminar on this topic. He is one of the senior most faculty member in our mechanical engineering department, and he has very good experience in the CAD modeling and analysis. I think he is the right person to give this type of lecture in modeling and prototype development. So I once again thank Mr. Amos. I hand over the session to Mr. Amos David. Sir, thank you, sir.
Thank you very much, Morgan, sir. Good afternoon, everyone. So here
Good
we
afternoon,
have
sir.
yeah, workshop on prototype or process design and development. The session is going to be like this. For the first 1 hour, we are going to have a direct where a slide presentation is going to be done. We're going to see about what is a prototype, what is process design, what is product development, all those data we're going to see. And then later on, for the next 1 hour, we're going to see online demo on Autodesk Fusion 360 on how to design a basic product and how a prototype is being designed. That's what we're going to see. So I hope I do justice to this topic in 2 hours. So we'll move on to the session directly. Am I audible and is the slide visible for everyone?
Yes, sir. Yes, sir. Clear.
Yes. Okay. Yeah. So ideas are born in the mind and brought into being at the point of a pencil. This is something that I liked very much when I went through this course. So basically, an idea comes only in your mind, correct? And it is brought into being at the point of a pencil. So that is where you draw and try to replicate it and take it to the next level. So pencil is what we use, and drawing is basically what we do. Basically, when you put an idea into a picture. So ideas can be communicated graphically. We all have seen in engineering graphics, the subject that the first semester that we into engineering we study that subject called engineering graphics. In that, you would have learned that ideas can be communicated graphically. So when you are trying to put an information to another person, you have to graphically represent as you're an engineer. As a layman, you can tell with the help of a lot of ideas, a lot of hand gestures and things. But when it comes to an engineer, you have to represent something graphically to another engineer. That is where you stand out as an engineer. So for this graphical usage, there are a lot of graphical softwares that are available. For example, we have Gamaleal, we have ProE, the latest Fusion 360, and then we have Autodesk Inventor, and so many. Every company has a software nowadays. In the olden days, like when I talk about 25 years back, everything used to be done with pencil and scale. So everything used to be drawn on a graphic sheet. There used to be a specialist called as craftsman who used to do all these things and uh, take it forward. But nowadays, software is there for you where you can start drawing it in the software and you can imagine how the prototype should be. That is what design process is. Now, what are the aspects of design? We would have seen in the olden days, when the ancient civilization, the cavemen, you must be knowing the cavemen, ஆதிவாசிகள்னு சொல்றோம்ல cavemen, அந்த cavemen பார்த்தீங்கன்னா they would have drawn these pictures on the caves, inside the caves. You might have seen those images and all. So I feel that that is where the first thing started, the design, where the cavemen started drawing on the rocks and inside the caves. That is where the first design started, and it slowly, as technology developed, things started moving forward, and we have come to the level where we can do 3D prototyping, 3D rapid prototyping, and 3D printing. We have come to this level currently. There are places where in European countries they have started building houses with the help of 3D printers. Huge 3D printers are being placed where using that they are printing houses. So from a day-to-day small thing that you can do in a 3D printer, but now it has come to a level where even houses and rocket parts are being printed. Do you know that? Did you come to know about it? Anyone? Rocket, rocket parts. Those are being built with the help of 3D printers nowadays. Elon Musk's SpaceX agency, they have given a contract to another company who builds rocket outer frame with the help of 3D printers. So we have come to the level where rockets are being 3D printed. So just imagine where design is right now. Now, creativity and design do not mean the same thing. You all agree? Because creativity is something which comes naturally, and that creativity has to be put into a design basically. So it's a combination. Creativity is a combination of imagination, knowledge, and curiosity. Whereas design is what? It's a conception of an idea and its development into a practical, producible, and usable process or product. So this is the difference between creativity and design. So creativity is basically you imagine something. Now let's say Leonardo da Vinci, he imagined a lot of things and he put everything into journals. He had drawn everything and he had kept it so that nowadays when people look at his journals, they are able to identify how creative he was. Whereas design is something which is conceptual based. Design is the conception of an idea and its development into practical, producible. So creativity can be anything. Okay, it need not be producible. All right, creativity it need not come into real picture. But if you are going to design something, it has to be practicable, it has to be producible and usable process or product. That's what design should actually be. Now, designers are concerned about these three basic issues. Alright, the first one is the look and feel of the final product, because when you buy something currently, take any product, a car or a bike, you go based on the look, right? Everyone? Can anyone unmute?
Yes, sir. Yes, sir.
Yes, you basically look at how the bike is, how the look of the bike is, and what is the cost of it basically. So the cost and look of the bike is basically same. So that comes under aesthetic design. Okay, aesthetic deals with the look and feel of the final product. So every company, excuse me, when they try to develop a product, the final stage they will try to make it look as presentable as possible, look wise and feel wise. Right? Any product that you take, a car or a bike or any domestic product, if you see the look and feel of the final product is very, very important. The second one is how it functions. Okay, now let's say I buy a car and if it doesn't do its operation for the next 1 or 2 years, means then the design is a failure. Understood? So it has to, if I buy a car, its lifetime should be at least 5 or 6 years minimum. Minimum it has to run for 5 to 6 years without any kind of issues. Maybe you have to give it for service in between and all those things can happen, but you have to make a car run for at least 6 to 7 years, 5 to 6 to 7 years without any kind of issue. That is what a successful operation of a final product is. So this comes under functional design. Next comes manufacturing process. The manufacturing process is the choice of materials. Alright. So this comes under feasibility of manufacturing. How easy it is for the product to be manufactured? Because if it's going to be very complicated, the manufacturing process is going to be very complicated, then it's not going to stand out in the market. So these things have to be always kept in mind. I'm going to show you a lot of case studies and designs that are there. So during that time, you can figure out what I am trying to say. The manufacturing process and the choice of materials. Now, if the process is going to be too complicated, then the cost, manufacturing cost is going to go up. If the manufacturing cost goes up, what will happen? Eventually, the product cost will also go up. All right. So all those examples I'll be telling you in the later stage. Now, what is this functional design? Does the product meet the functional design objective? Does the product meet the functional design objective? You see, form follows a function. A function, what is a function we are going to see? Have a look at it. This is the function aspect of design implies that the product will perform the manner for which it was intended. Alright, so what it means is it has to perform in the manner for which it was intended. Now, as I said, a car, if a car, what is the basic usage of a car? To commute from one place to another. Alright, so if it doesn't satisfy that particular condition, what happens? This whole functional design fails. Do you understand my point? So this is what happens. So a product, if it is being designed, its performance and the manner in which it has to be, the performance, how it has to do, it has to be perfect. Okay, this is what functional design is. What about aesthetic? As I mentioned, aesthetic is the look and feel of the product. All right. So basically, we go for color, line, style, space, contrast, proportion, balance. All these things are taken into account while building any kind of. This is the image that you're looking at is a Formula One car. Let's say it's a Formula One car. So all these things are taken into account while designing a product. For example, the look of a product is often designed to send message or feeling about a product. So if there's a brand, let's say Apple brand. Apple brand stands out from all the other brands because of its aesthetic design. You know, right? There are a lot of people who prefer Apple. In the US and all, Apple is very, very famous because the replacement policy that they have is great. If the phone or any Apple product, if it breaks, they will under certain norms and certain things. What will happen is they will replace the product fully for you without any kind of extra charges or anything. Apple phones or any kind of Apple products will be replaced without any extra cost. That is something that you should be knowing. So these kind of things attract customers basically. So as aesthetic design. Then engineering design. Engineering design is the creative problem, or it's a solving process where, now let's say there is a problem in your society. All right, there is some sewage issue, or there is some kind of water scarcity in your area, basically where you are right now. Okay, so what you can do as an engineer, you can come up with a solution to that. All right, you can come up with a solution, and what happens is you are becoming a social entrepreneur basically when you come up with the design with related to a society. All right, so what happens is you become a person who's trying to find a solution for the society. So what happens is you become a societal engineer, or there's a term called societal engineer or social entrepreneur, where you start making money out of it. That's what basically is engineering design. So you have to have this habit of having a lot of creativity in you. I hope all of you are mechanical engineers here. There is a very good percentage of creativity in a lot of mechanical engineers, because the way your curriculum is being designed from first semester till the 8th semester, the subjects are in a flow that it brings a lot of creativity in you. That is why we are into CAD and we are into manufacturing. Any department you take, like let's say a communication or something, we'll be able to go there and survive. Or triple E, we'll be able to go there and survive. If it's IT or CSE or anything, robotics, anything, we will be having basic knowledge about everything. So mechanical is something that is what to say, as it is said, as a core subject, core department. All right. So you will be having a glimpse of every other technology in this current world scenario. Anything latest, if you take rocket science, you will be having a part in that. All right. So this is what engineering design basically is. So design Designers and engineers are involved in aspects of design process. Drafter needs to be familiar with each step. Alright, so as I mentioned in the beginning, drafter, he is the person who drafts it for you, drafts the design. Right? He has to know the each steps in a very, he should be familiarized with all the steps. What are the procedures for designing? Everything has to be known clearly. And how the initial sketches are being made, how the final presentations are being made, everything has to be known by the drafter. So if you are going to become a drafter, you have to have very, very good sketching skills basically. Alright, I'll be showing you how a sketch is being done and all. So sketching skills is very much not with the software, but with a pencil and a paper. Alright, so that is something that you should be knowing. Then what is the design process? Basically, design process comes under two designs. One is traditional engineering design, and the second one is concurrent engineering design. Traditional approach and concurrent approach is what we are going to see, right? Let's look at it. TED in short. Traditional engineering design is TED. I will directly go to the comparative. This is the process. So basic idea is created or problem is assigned with design engineer. So if you're going to become a design engineer, these are the things. The idea, basic idea will be given to you, and you will be asked to create a solution to that problem. All right. So what an engineer does is, the design engineer does is, he analyzes the need for the product and what is it needed for, or is it needed? Is it exactly needed? Is it needed at this moment? All these things he will analyze, and then the objectives are set. Okay, these are the things that has to be met. Objectives are to be set. That is the third point. Then the fourth point, ideas are being created. Ideas are created through a lot of means, like brainstorming sessions will be carried out. Through a lot of means, what will happen? Ideas will be created. If you create ideas, let's say there are 20 or 100 ideas will be there, but from that 100, you should know how to narrow down those ideas. That is where you stand out. Alright, you have to narrow down those ideas. So basically, what they will do, if there are 100 ideas, they will put it all into certain groups. That's what a design engineer does, right? When any project is handled by any kind of company or something, the design engineers, they will all come together, and what they will do, they will try to categorize the ideas into certain groups. After choosing it into groups, they will pick a certain group which is having all the features basically, right? All the features put together. From that group, they will choose those ideas and they will try to bring a prototype out of it. So that's what this traditional engineering approach is basically. So the best solution is picked, maybe prototype for further review. All right, always there should be review that should be happening, because if there's any kind of issue with that, during the review you'll be coming to know about it. I'm talking about the sixth one here, sixth process. So during the review, if there's any changes that have to be made, it has to be gone. It has to be told to the draftsman again, and right from sketch, the thing has to be sorted out, so that there is the best solution has to be picked up. All right. Then the prototype goes out to be evaluated. If times of problems found, goes to step 4 again. So if there's any kind of issues with the prototype, let's say the prototype is being tested. If there's any kind of issue with that, then it has to go back to the ideas and idea generation. So it's not a simple thing. Have you seen those near a college in the Kanchipuram Sri Perambuttur area? You might have seen cars being close to clots and running. Have you seen that? Anyone? Cars running on the road with the covers all over it. Have you seen it? Anyone?
Yes, sir.
Buses,
Yes, sir.
buses also, trucks,
Yes, sir.
lorries and all. So what they are basically doing is, they have designed the product. Okay, a prototype has been designed, and the prototype is being tested on the road, like checking for its maybe efficiency or fuel efficiency basically, or how fast it goes. All those things are being tested. If you had seen cars with closed covering and all that, what it means is it's being tested. Okay, that is the only vehicle they would have done basically. Maybe a few more will be there in the company, in the plant. But this product, this unit or the model is being tested in the outside world. Okay, that's what everybody does. Hyundai and all, no. So when to come to that extent, it would have taken them 2 years or 3 years continuous study, like idea generation, all these things. The best to bring about the best solution. What they will do, they will keep doing this process again and again till they get satisfied with the product. All right. When they get satisfied with the product, that is where they start manufacturing it basically. Right? So they don't go for manufacturing directly. Maybe 1 or 2 units they will manufacture. But to come to this level, they would have worked for at least 3 to 4 years, minimum 3 to 4 years, to come to a final product. So the final drawing or the product is being created in the last stage. So whatever I discussed so far for the past few minutes is a traditional engineering design approach. This is what a traditional, a conventional, also we can say conventional method of designing something. Alright, there's something called as concurrent engineering design. Alright, what happens in concurrent is, I'll show you the picture. Okay. What happens in concurrent is everyone works together basically. Right? It's starting from the design, the engineer, or the craftsman, or the manager, or the manufacturing plant head. Everybody sit together and try to come up with a design. You understand? So everybody, they all come up together and they try to do the product. Okay, so the team consists of all the aspects of design, manufacturing, marketing, and servicing of the product. Everybody, people who are into service. Service is something that comes at the end, right? After the product is being delivered into the market. And if the product needs to be serviced, that person comes in, service technician or someone. They also will be called for and everybody will sit together and work on it. So what happens basically is every input is being taken. You understand? Design input. When the designing is being done and the manufacturer, the manufacturing head, what he will do is he will tell, right? At this point, there will be some issue with the manufacturing. So let's change this particular thing in the design. So you're getting direct input from the manufacturing head. You understand the point? All right. Then, if the feel, look, or something, okay, if it's not good, the marketing guy will say, this thing will not go well in the market. So you have to start looking into the aesthetic feature, like that. Marketing guy will say, all right. If the cost is too much, or if it's beyond a certain limit, what the marketing guy will do is for this value, nobody will buy in the market. So you have to work on it and reduce the price. So the marketing executive will say like that. So all the people work together and the product will be brought about. Okay. So when everybody involves, what happens is the time it takes to make a product reduces drastically. So in concurrent engineering, what happens basically is if it takes for a product to come to the market, let's say 4 years or 5 years, in just 2 years, using concurrent engineering, the product can come to the market. That is how the current scenario, this is the current scenario in all the manufacturing plants, right? If you have seen Hyundai, okay, for every 2 years they are releasing a car. Did you notice that? You might have seen those advertisements in the TV and all, right? Every 2 years they're coming up with a car. So this is what they do basically. They do concurrent engineering design. They don't go for traditional. Traditional approach is something that is constant. Okay? There's not going to be any kind of failure during traditional approach at all. But in concurrent engineering design, there might be huge failure, but the product can come out very, very, very fast. Okay. Nano, for example, nano car, right? It came out, but did it go well? How many of the people that you know have a nano car? Anyone? Can you unmute? Did it go well? Nano, did it go well or not? Is it a success or a failure? Nano. Failure. Right? They wanted to come up with a cheap car. It had everything. It had all the features of a car, and it was satisfactory. But many people didn't go for it. Right. They were ready to buy a 3 lakh, 4 lakh car compared to a 1 lakh or 1.5. Okay, final rate of a nano, they said 1 lakh, but later they added some features to it and it became 1.5 like that. They were not ready to buy a car which is worth 1.5 lakh. Instead, they went for a 2.534 also they were ready to go and buy. So there was a huge failure in the nano design. So all these things have to be taken into account. Alright, is what concurrent engineering is. So this is a comparative statement about what is traditional and what is concurrent. So look at it. Traditional is a linear process. Right, as I said, when the modeling is being done, after that the manufacturing comes, after that the marketing, the production, marketing, and then servicing. But in concurrent, everybody will be involved. So look at the second point. Chief engineer responsible for most of the design process in traditional. Whereas here, everybody is responsible, right from CEO till the lowest person who is working in the company. Everybody involved would be involved in the concurrent design, right? And if something starts, let's say a process starts, okay, until it finishes, the whole thing has to wait. Understood? Whereas in concurrent design, they can do multiple areas at the same time. The last point, multiple areas can be done and covered at the same time. Whereas in traditional, start on next phase until last one is done. Only if the previous product is done, then only I can go to the next product. So this is a drawback in traditional design. Right? So there's something called a product life cycle management. The product life cycle management is we all have this some kind of vehicle we all have, right? At least a bike or bicycle or a car. Imagine maybe our parents they'll be having a car. Okay, or sometimes you will also be having a car, right? Now, what happens what uh, happens if you are going to sell the car to someone? You are selling it to someone. But what happens to the life cycle of this particular car? Have you ever thought about it? Anyone? Can you guys comment? Have you guys thought about it? You are having maybe let's imagine you have bought your first bike, but now you are having maybe after so many years you have bought the third bike maybe. What happened to your first bike? What happens to it? Have you ever imagined it? You are selling it to someone. He is selling it to another person, another person, another person. Do you think that after 10 years it will be still in use? What would have happened? I mean, engine would have failed, and where would it would have ended up?
Lack of
Yes, yes. It would have ended up in a junkyard, basically. All right. So, creating and releasing the product is not an important thing. How the product life cycle ends also matters. Because if I take a car, it weighs, let's say, a few ton, okay, 1 ton, 1,000 kg a car weighs, let's say that. Okay, that 1,000 kg of metal has to be disposed if it is not in a running condition. Understood? Okay, so it has to be sent to the junkyard in the end. All this thing, the whole right from the design stage till the stage is different stages where it is being manufactured and finally where it is being thrown off. Okay, till that this is called as product life cycle management. Okay, some people what they will do, they will take the scrap and they will recycle it, again make some product out of it. Maybe not a car, maybe some other product out of that particular material. Understood? So these are certain things that you should be knowing. So this is what basically content engineering is: refinement, ideation, implementation. Everything together, all will work at the same time. Alright? Let's move product. Yeah. This is important now. What is a product? Look at it. This is the explanation that I got. A product is defined as a thing produced by a labor or effort, or the result of an act or a process. So product is something that is coming out of some effort. Understood? So they'll say you are all products of Panimalar Institute of Technology, correct? That means that there are certain people who are working towards your future and efforts are being put. So that is why you are called as a product. Understood? Same way, a lot of efforts are being put, okay, and then the car is being developed. Okay, all the laborers in the manufacturing plant, they are putting a lot of efforts to it. So that is how a product is coming out, right? Then, what is product design? It is a process of creating a new product. Now, whenever I say a new product, just think, what if that product already exists in the market? Will your product go well? It will be a failure, right? If the product exactly a similar product, if it exists in the market, if you're trying to develop products very similar to that, what will happen? Your product won't run so well. If your product has to run well, then it has to have lot of extra features compared to your competitor in the market. Understood? Now, let's take, for example, if you're trying to develop a phone, okay, now current there is a very famous brand, Micromax. Yeah, I forgot the name. Micromax, it came in. Okay, in a very few years, it went to the top level in India. The sales of Micromax was at the top. Okay, they were able to sponsor a cricket match. Okay, a cricket match between some two countries. Okay, India is playing. Micromax Cup they were able to sponsor. Do you guys remember that time? 4 or 5 years back I'm talking. Micromax, they had so much of funds that they were able to sponsor a cricket match. Imagine trying to sponsor a cricket series. It's not a small thing. They have to spend crores to have that kind of publicity, right? And they have that much money. But where is Micromax right now? Where did they go? They are trying to come up with different ideas and things. They are still working on it. I read last year during the lockdown. I read that they are trying to come up with some new products so that they can come back in the market. They are no more in market anymore. 2 years they are not in market. Alright, they are not. They have stopped the production, everything, service, everything has been stopped. This they are trying to come in again. Okay, similar thing. Okay, there is this very famous product that you know of, which went off without any kind of trace. Any other product that you know of? Can you guys tell? What is it? Ambassador. Yeah, but they were not able to cope up. Correct. Cope up with the marketing trends. They were not able to cope up. Any other?
Nokia.
What is it?
Nokia.
Nokia, very good. I was expecting that answer. Okay, Nokia, they were not able to compete with Apple, and what they had to do, they had to shut down their business. At the brink of a failure, or when they were in a huge loss, who went and bought it? You guys remember? Who went and bought it? Microsoft, yes, Microsoft went and bought Nokia, and they thought of trying to make it to a big level, but it was a huge failure again. They were not able to go for the next level at all. But now, slowly Nokia is trying to make its footsteps come back again. Okay, they are trying to make a mark in the world with some new innovative products, right? So this is what basically product design is. Now, what is the scope? Right? Just look at these words: product design, industrial design, defense design, service design, game design. See, so many scopes are there when it comes to product designing. Okay, web designing, application designing. If you're good at web designing, is anybody into web designing and all? Yeah? No one? No one? Okay, it is so simple actually. Web designing and all, you might think that you are doing a lot of coding and all. But now, there are a lot of templates that are available. Using those templates, you can just design a website in just a few hours itself. You can just design a website, right? Okay, so there are a lot of things that are open to all nowadays. So it's not that mechanical engineering is only related to industry and product. You can just jump into any kind of these designs and still you'll be able to succeed, right? So this is basically how product design process is. So strategy is first being made, and then analysis is being done. Then specifications are fixed. What kind of specifications we have to produce a product that is being fixed. And then the design is being done, and then evaluation of the product. If the evaluation is not proper, then they have to go back to the analysis again. Okay? This is actually a loop. If the evaluation is not good, the evaluator is not evaluating, I mean, it's not the remarks that is being sent is not proper. What they will do, they will have to go back to the analytical stage, come back, design it, and then come back to evaluation. If everything is satisfied, if evaluation is okay, then only the product will be launched. Okay? So this is how a product design process basically works. Right? So I think just go to some case studies. I just have to. I was going through the net. I just came up with some case studies. Just have a look. So usually when in our stage, basically in a student level or in a college level, this is how design basically works. A student comes up with an idea, alright? He talks to a person, okay? He is the guide, right? So during your final year project or in your third year project, you have done. You'll be having a guide, right? Everybody is consulting a teacher, a college professor, for a guidance. And what they will be having another person to guide them as well. Okay, in case it's going to be a product which has to be developed. If it's just going to be a project, then it's going to be this student and the guide. If it's going to be a product, okay, then the co-guide might be an industry person. You understand the concept? Okay, because a guide, he is only from a college background, right? When it comes to a product, if it has to be done, then the co-guide will be from an industrial perspective or industrial background. So all these three people form a team. Okay, all these three people form a team. Now, this is called a SAP lab analysis. Always remember this word, SAP lab. This was introduced by one of the IIT professors called Dr. Chakravarti. Okay, SAP lab. Okay, look at it. S stands for situation. Upon which situation you are doing the product. Okay, that situation has to be analyzed perfectly. Okay, and next one is the actor. Actor means not the Bollywood or Hollywood actors. Actors is who are the people who are involved. Okay, the student or the guide or the co-guide, are they involved? Okay, who are the people who are involved in the project? You have to finalize them. They are the actors. They are the people who are going to do the project. And the process, P stands for process. Process has to be finalized, right? Which process we are going to follow, that has to be finalized. Then comes the learning. Okay, so regarding the product, if anything has to be learned, okay, those things have to be learned by the actors. Right? The learning is a continuous curve, they will say, no? Learning is a continuous curve. So even during product development, people will go and take consultation from someone and they will learn actually. It's not like they will do everything with their own knowledge and things. So they will be ready to learn. Then they go to the action, the second A. Okay, it's the action. Right? Then comes the performance. How the product that you have done is, action is where it's being manufactured, and then the performance is how it is being performed. You're going to check it. Okay? Always remember the SAP lab. Okay, SAP lab. S the situation, A is actor, P is process, L for learning, A for action, and P for performance. Okay? Now, we're going to look at this hero cycle. All I've seen hero cycle, old, very old cycle, still it exists. Yes. Yes? Yeah. Okay. So everybody would have seen or would have driven this cycle actually. Okay. This particular case study was carried out in IIT Bombay. Alright. I just happened to come across it and I just wanted to share it. Okay. How is the frame of a hero cycle look like? Can anybody answer? How does the frame look like? Is it a rod, or how is the frame basically is it sheet metal, or any kind of rod, or how it is being made? How's the bicycle, the Hero Cycle's framework is frame? How is it? Anyone?
It's a rod only.
Rod. It looks like a rod. And don't look at this one. I've just put just an image. A Hero Cycle basically, what is the frame? It's a rod, right? Rod, correct? Now, this IIT Bombay people, okay, people from there, they got this particular case, that is this particular project from Hero. Hero company, they approached IIT Bombay, okay, when they wanted to first come up with cycles, right? They approached IIT Bombay, and IIT Bombay had this they did this SAP analysis. Okay? Situation, what is situation currently? Okay? In the Hero company, what they were doing is they were producing 24,000 bicycles per day. This was the current situation, right? How many bicycles? 24,000 bicycles per day they were producing it. Okay? Most of the work, okay, that the bicycle frame welding or anything, okay, most of the work were outsourced to external vendors, right? What were they doing? This is situation. So they went and found out what is the situation happening in the company, right? So most of the work, okay, like welding of the frame or the fork of the bicycle, all those things, or the seat or anything, or the spring below the seat. You remember there'll be a spring below the seat in Hero Cycle, and seat for suspension. Okay, for when the bike goes into any kind of ditch or anything, what happens? It will vibrate. Alright? There'll be a spring below the seat. Got it? So all those things, everything, most of the work was outsourced. Okay, they found out this particular important thing. So majorly what they were doing is they were just assembling the parts that they get from the vendors in the company. That is what they were doing basically. Okay. Then they were not capable of producing high quality products. Okay. This is something that they found out. The Hero company, what the IIT Bombay people who were assigned this project, they found out that they were not capable of producing high quality products. The quality of the bicycle was not so good what they were producing. Then the CEO of that company, they gave them full freedom to innovate on this particular product. Company CEO, okay, the owner of the company, he told the IIT people to have all the freedom to do whatever they want with the cycle, but come up with something that is it is better than the actual product right now. Got it? It has to be better, and then it has to go up in sales. Okay, it has to give them very good profit margin as well. So what they found out was there was a stiff competition from China during those times, right? Chinese cycles that were being imported during that time, was the cost of the cycle was very, very low compared to what Hero Cycle was selling, right? So this is something that they found out. Now these are the different prototypes that were done. Look at, can you see the screen?
Yes, sir.
Just with the help of pencil and paper, they have done these kind of sketchings. So this is what basically every design engineer does. Okay. Here, if you're not able to do this, you can do this with the help of a software. It's not like you should be very good at drawing these kind of arts or anything. This is one medium of sketching. Okay, this is one medium. If you're not good at this, you can obviously go with the CAD software. Okay? So IIT people, what they've done is they try to make the frame in different shapes. Can you see the first one here? Okay, it is somewhat like straight. Okay, what about this? Look at the framework. The bike frame looks different. The green one. Look at the bottom left one. Okay, it looks more like a stylish, very stylish frame. And then the third one is with a cannon barrel look, cannon barrel, Achilles cycle, that kind of a look. So they had to go through this. I've just put only 4 here, but they had hundreds of bike frame designs. Imagine, people, so many students were involved, so many researchers were involved in this project, and they had to come up with lots and lots of designs. Okay, all the designs were taken. Not even one was ruled out. Okay, this is an important thing that you have to understand. Okay, you should not rule out anything in the beginning itself. இது நம்மளால முடியாது, this design is not possible. So we should not take off anything in the beginning. Every design has to be put, and what they basically did was they categorized it. Okay, they categorized it, or clustering. It's called as clustering. Look at it. They found out that this cluster is something that they came up. Okay, look at it. What they basically did was they tried to how a basic cycle is being done is sheets. Okay, the metal will come in the form of sheets. The sheets will be rolled and the bike frame will be formed. Okay, the rolling process it takes is too costly. That is what they found out. Got it? The sheet metal is being rolled and made into bike frames. Okay, it's being rolled and the bike rods kind of things it's happening. Okay, so what happens is they found out that the cost for rolling this particular sheet metal into rods, it's somewhat costlier, and the welding that has to be done. Okay, if I just roll it, it doesn't mean that it will stay firm. So what they have to do? Wherever it is coming, wherever it has to be welded, and welding was also not being done properly. So because of that also there was a lot of failure that were occurring. So what they thought was, why don't we come up with a frame made out of sheet metal itself? You understand? Instead of having bike frame with the help of rods, what they came up with was, why can't we have a sheet metal based bike frame? So these 4 designs is what that they came up with. All right. Then look at this. Okay, so this was developed with the help of CAD models. So just with the help of sheet metal only. It doesn't have any kind of rods at all, no bike frame or anything. Okay, it's all purely based upon sheet metal. So they came up with this idea. All right. So this actually reduced a lot of cost for Hero. This proposal was given to the company, and the company started using this, and they were able to make a lot of profit out of this. So this is a case study that I just came across. All right. Next, look at this dual chamber bottle case study. All right. There was this company which approached one of the IITs, same IIT in Bombay, and they wanted to sell masala milk. Okay, masala milk, right? What they wanted was a dual chamber. Dual chamber means the masala has to be in the top chamber. When the person wants to drink it, understood? When the person wants to drink it, what he will do? He will take the top chamber off and he will put it inside the bottom chamber. And at that point only, the masala will mix with the milk. All right, and he has to shake and just drink the masala milk or masala lassi or whatever. Understood? Not lassi, we call it buttermilk, more. Okay, like that. So they wanted to have, they came with, they approached IIT Bombay, and they wanted to have this kind of a bottle that has to be designed. When needed, it has to be punctured. Okay, like punctured, and then the masala has to be poured inside the bottle. So they were able to develop these kind of designs, as you see on the screen. Okay, they came up with the rolling thing. Can you see the last one, right hand side, as I'm pointing? Can you see your three openings there? 3 openings there. So when it is rolled or just twisted, automatically the masala will fall inside the drink. Understood? This kind of idea they came up with. All right. So this is something that innovation that happened. Okay? It's something that the IIT people they the company got very, satisfied with the product, and you might have seen this kind of products coming up in the market also. All right. Cost has to be taken into account. The design has been done by IIT Bombay, and it I think is the proposal has been given to the company, but it is the company's what to say is their own thing whether to take it up or not. Understood? Because cost of this might be, if it is very high, then there is no point in selling this product in the market. Understood? So they had to maybe drop the idea or something. I don't know. So what happened is that have you seen this product anywhere where if it twists, the top thing will fall inside the bottom? Maybe not in our country. Maybe in foreign countries it is available, I think. Okay. Noodles on the bottom there will be noodle, and the masala for the noodle, it will be on top. And it is being twisted, the masala will fall inside the noodle directly, so that the aroma and all those things will be fresh. If it is mixed already and it is being sold, what they will do? It will not be so aromatic. The smell and taste won't be so good. So at the time of eating, what they can do, they can just twist it and it will fall inside. Right? These kind of things exist. Okay, if you don't know, I'm just telling. And then Godrej lock case study also was done by IITs. Now, these are certain design failures that I just came across. Okay. This is the coolest cooler. It's called coolest cooler. Have you heard about this thing called Kickstarter.com? Have anyone heard of it? Kickstarter.com. Hello? Can anyone comment? Kickstarter? No one? No one, no? Okay. Okay, Kickstarter, it's a website. Okay, it's an organization or just a website where you can, if you have a fully developed product, okay, what you can do, you can post it in their website, okay, and people will be ready to fund your project. Understood? Got it? Anybody can do that. Not necessarily that Americans only can do it. Anybody around the world can have products, okay, which are fully developed, and it has to be in working condition, right? Like how we have a condition in our DAF, design and fabrication project. It has to be in a working condition like that. Okay, same thing. Those products can be posted, but make sure it is something novel. Novel means it has to be new, not something which already exists. If it already exists, you will be sued for that. Understood? They'll put a case on you if you are trying to sell someone else's product, claiming that it is yours, right? So if it is going to be totally new, you can log into their website, Kickstarter.com. You can go check it out thoroughly as you are all online, Kickstarter.com. You can go there and post your product, and people, if they like it, there are a lot of investors in that particular website. Okay? Investors who have money and who wants to make more money out of it. What they'll do is they will fund you, and you can start manufacturing those products with those funds, and you have to give a portion of that cost for the people who have invested, and you can keep a profit and you can churn the profit. Understood? You can take the profit, and the money that was being invested has to be returned. Okay, this is how the framework works. Now look at this thing, coolest cooler. This was developed in 2014, the Kickstarter. Okay, this is a handy thing. Okay, which is a portable thing basically, which can be taken outside. Okay, when you go out for a picnic or if you're going for a road trip or something, you can take this and go. All right. It has a mixing jar, that is mixer, and there are a lot of things associated with it. Okay, but the cost of this product was $400. Okay, when it came into the market. Okay, the cost was so huge that people were not able to afford this particular thing. So you should always remember this. You can have very good design and everything, but if the cost is too much, what happens is it will not go very well in the market. So such a beautiful design, but it didn't go well at all in the market. So the thing has been shut down. Okay. What if he had the person who has created it? Who has done it, created it, I sold it for like $150 means then definitely this product would have been hit in the market. Okay. It's called as cooler. One of the first, this stands as first in design failures. Okay. Design is good, but it didn't go well in the market. Look at the second one, Google Glass. Okay. Do you like the frame of this glass? Anyone?
Yes, sir.
The way it is being shaped?
Yes, sir.
Yes. More or less looks like a welding glass, no? When we put in our first semester welding lab, no? In our workshop.
No, sir. Yes, sir.
Yes. Okay. So this was the failure in this model. Okay, the shape in which the glass was. This actually is cost $1,500. What it does is, it has camera. Can you see a camera here? Can you see a camera?
Yes, sir.
Okay, it takes data from the camera, and this screen, the glass frame, the transparent glass. This is actually a screen. Just imagine this is actually a screen. Okay, so whatever you see, okay, and any data that you want from your mobile, that data will be displayed right in front of your eyes. Okay, like how you see in the movies. Okay, that was how good this product was, but it didn't go well at all because the cost was so high. It is not affordable by any a common man. Can we buy such a big thing? How much does it come to in Indian rupees, Indian currency? 1,500 means how much? $100 means 7,000. Just rounded off. So 15 into 7. How much does it come to? Yeah, for a glass, okay, which is having this kind of feature, 1 lakh, so much rounded off 1 lakh is not worth it. Okay, so this was a failure in this particular design. Then comes 3D television. Did you come across this 3D television? It came up in a lot of advertisements. Of Sony actually had this kind of technology involved. 3D television, where you can watch the
4:30
depth in the TV. Usually we watch only the length and the breadth, like the depth also, like how we go for 3D movies. 3D movies we go and sit with the glasses, right? 3D glasses. Just like that. From home itself you can have a 3D feeling. Okay, this was developed by LG, and this technology was used by a lot of top companies, television companies, electronic component manufacturing companies, but it didn't go well because what is the drawback in this? Can you tell me? What is the drawback? Once or twice I can watch a 3D movie, correct? Okay. Let's say I have to watch a serial, okay? A serial which is running in a local channel. Will I be able to watch that in 3D? Just imagine. Okay, so that was the failure thing in this particular technology. Everything cannot be watched in 3D. Understood? Maybe just for 1 hour or 2 hours, I can watch a 3D film in 3D. 3D mode. But everything I cannot. So imagine the family sitting with all the glasses in the living room. Will it look good? Will it look good? Anyone? All of them sitting with glasses and watching TV all the time, 24/7. Okay, will it be good? It sounds funny, Okay, that was the failure in this model. Now this is a very interesting thing that I found it very, very funny. Okay, this is a juicer, it seems. Okay, and the juicer, what a juicer basically does, tell me. When you put fresh fruits inside, it will squeeze it and it will give you a glass of juice, right? Okay. What this juicer press, what it did was, the juicer press, it comes with a sachet. Okay. The sachet is being sold by the company. The sachet is going to have the juice inside. Okay. This equipment, what it will do, when you feed the sachet inside, it will just squeeze the sachet and the juice will come into the glass. Just think how funny it is. It is just the sachet Okay, you can just open the sachet in hand and you can just pour it. Like how recently, I mean, nowadays it's available now. It comes in sachet with a small tube outlet. Okay, tube tip. Have you all seen that? 10 rupees, 20 rupees, you get paper boat. Paper boat, have you seen? Okay, you can open it in hand and you can just drink it directly or pour it into a glass and drink. Okay, look at this. These people have developed, Juicer of this company, they have developed this equipment where it is not even a fresh juice. That juice is also, the sachet is also being sold by the company. Okay, when the sachet has to be loaded, the sachet when pressed, the juice will come out of the sachet. Understood? So this was a huge failure, and it was sold for $400. I can just open it in hand and just pour it into the glass and drink it. This happened in 2017. Then this one, a very famous. I don't know how many of you have heard this. After iPod came, iPod. I don't know when it was released exactly. Microsoft, they tried to release a music player. Okay, just similar to iPod. Okay, an MP3 player basically with the name of Zoom. Okay, Microsoft Zoom. And it was not able to compete with iPod at all. Okay, Apple's iPod, it was at the peak. I don't know, like when I was in my college days, I bought my first iPod when I was in my second year. And it costed 3,500 rupees at that time. And you know how many songs it can store? It can store 120 songs, that's all. 120 songs in one iPod shuffle. It was called iPod Shuffle, and it was sold for 3,500 rupees. I'm talking about 2006 when I was in my second year. So imagine, okay, such a now in your mobile phone, how many songs can be stored? Hardly.
Now 10,000.
10,000 songs. Okay, minimum 10,000. Depends on the file size. Okay. That has to be taken into account. So just imagine 2006 what was the situation and what is the situation right now. Okay, 10,000 songs. If you take an Apple phone and all, it is much more bigger. If it's a 64 GB phone means if you're having 64 GB memory, imagine how much you can store, how many songs you can store. Okay, so things have moved so fast in just hardly 10 years. So when Microsoft came up with this particular thing to compete with the Apple, they were not able to survive in the market because none of us know this brand, Zoom. Okay, this was by Microsoft. Okay, so till 2006 to 12 it was in the market, but then it lost its way. All right. Yeah. So what basically people have done during this time is, I mean, how when a product is being developed, you have to identify the opportunity. Okay. Identify the opportunity in a particular area. Now, let's say in your area there is some shortage of particular thing. Okay, what you can do is you can go supply that in your area and you can start making money out of it. Right? So this is identification of opportunity. This is what Dhirubhai Ambani did. Okay, when there was a huge manufacturing boom, manufacturing and civil engineering, mechanical and civil engineering was at its peak. Okay, there was need for textile in the in India. Okay, so Dhirubhai Ambani, that is current Ambani, Mukesh and Anil Ambani's father is Dhirubhai Ambani. What he did was he saw this opportunity. Okay, what opportunity? It was there was need for textile in the country. Okay, because all the textile was being imported from foreign countries, so he wanted to manufacture his own brand. Okay, Vimal, have you heard about this brand called Vimal? Vimal suits. Even Dhoni, he does sponsor for that. He's a brand ambassador for Vimal. Have you heard of this brand Vimal?
Yes, sir.
That was the first brand that was done by Dhirubhai Ambani under Reliance Group. Okay, under Reliance, that was the first branding which was done, and that was Vinyl. Okay, which was purely for textiles. Okay, if you can just go browse and see, Vinyl was a brand name. So what they basically did was they didn't do the manufacturing of the textile in the beginning. What they found out was in the villages there was huge production of textiles. Okay, okay, kaitari, okay, that was being done hand woven textile that was being produced by the people in the villages. That was bought in bulk. Okay, that was bought in bulk by these people, and what they did was they basically went and sold it in the market for a higher price with a brand name called Vimal. You understand? And later on, they started manufacturing the textile by themselves. This was how they began. Okay, and now you know where Ambani Group is. Where they are one of the leading people in every business thing in this country, as well as they are competing in world level as well. Okay, Mukesh Ambani is one of the richest man in the world. So they are into everything. Like how Tata Group is. Tata Group is the biggest. Okay, nobody can reach Tata. Okay, these people are slowly nearing Tata because they are into every perspective. Okay, then you should have a clear vision basically. Okay, like how Elon Musk, Martian colony, he is trying to. I mean, he's already into the work of creating a Martian colony. Martian colony is in Mars. Okay, developing a colony in Mars. And then Hyperloop. Have you heard about Hyperloop? Anyone?
Yes, sir. Yes, sir. Of course, sir.
Hyperloop. Fastest way to commute from one place to another. Transport. Okay. From one country to another country, you can just go in 1 hour or half an hour in just such a short time. And it has been tested as well. How many of you know that it has been tested? It has turned out to be successful. Virgin, the company called Virgin,
Yes, sir.
they have done the testing with just two-seater shuttle. Okay, two-seater shuttle was done, and they were able to go at speeds with unimaginable speed. Okay, using Hyperloop concept. Okay, and
In vacuum, sir.
yeah, it travels in vacuum, so it goes very very fast, unimaginable speed. Yeah, not like bullet train and all. It is so many times faster than bullet train. It goes so fast, right? Then look at this person. You know him, right? Who is he? Infosys founder. Okay, Mr. Narayana Murthy. Okay, when he started off, he had this team of 7 members along with him. Okay. When he started off Infosys, at that time, there was no software companies in India at all. Okay. As I said, during these time of Narayana Murthy and the first person, Dilbhai Ambani and all, they lived in the same era basically. I mean, Dilbhai Ambani is very much senior to Narayana Murthy. What happened? There was huge boom. Okay, boom was happening in the field of mechanical and civil only. Okay, there were a lot of construction that was being done, and then there were a lot of
Sir, is it audible?
mechanical companies that were coming in, manufacturing plants that were coming in. At that time, they saw this opportunity for the need of software. Okay, and then they developed this Infosys, a company called Infosys Private Limited in Mysore. Okay, to help with a combination of 7 members. Okay, all who are into computer science field. Okay. This is what Infosys started. This is how it started. And then resource guarantee. Mukesh Ambani, he came up with this Geo idea. Okay, when it came up, what was the condition? Geo was free for all. Do you remember?
Yes, sir.
Okay. Geo was free for everyone. You just have to go with your Aadhaar card. I don't know like whether you did that. Okay, you have to just show your Aadhaar card, and they'll just give us a SIM directly. You need not pay anything or anything. Nothing. You just have to pay some initial cost. 200 or 300 rupees, I think. Does anybody know that?
Yes, sir.
And after that, it will be. How much?
Only 19 rupees, sir.
Yeah, 19 rupees. Yeah, I forgot. It's been a long time. And after that, when everybody started using Geo as an alternate number, they didn't switch over to Geo as the main number. What they did, everybody wanted to have another number, so everybody went for Geo. And what they did after that? They made Geo as paid. Then they started making Geo as paid one. By that time, what happened? people started using 0 as the main number because it's free. No, 1 to 1 it is free. Anybody you can call, it was free all over the India. Understood? So when people started making 0 as the primary number, from being secondary to primary number, that is where they kicked in. Okay, they said, now we are going to charge so much for per month, like how other companies are charging, like how Vodafone, Airtel, every other company is charging. So now people have no other option. They had to go recharge Geo as well. This is what a business plan is. When we started off, they gave it for free. So everybody ran behind Geo, but now now we have to have talk time also. It's not even this thing. Geo to Geo only free. If you have to talk to some other mobile numbers or not, it costs. Okay, so they are slowly becoming like a normal service provider. Understood? So this, look at this business plan. Then, look at this man. In Tamil Nadu, they have one of the largest solar plants. Okay, somewhere down south in Ramanathapuram, near close to Ramanathapuram. Okay, they have a huge solar plant they have developed, and it is running. Effectively, it is running and is able to produce so much of generate so much of current out of solar power. And this is something that this venture, this is how they venture into. These are different plans, business plans, how process is being done. And this one I already discussed. Okay, how Nokia failed in the beginning. Okay, because of non-enhancement of technology. They didn't have much technology in their phones. And all the other companies, Samsung, iPhone, there is Apple, and all the other companies, they were going up in technology. Nokia failed to do it because the issue was the companies, the people, no, they were not going and telling it to the head. It seems that was the when I just went through this failure story. What I found out was people were so scared to go and tell the head, the chief, that our product is failing because of this particular thing. Everybody in the bottom level, they all knew that the technology is not advanced. The technology was not going up in levels. If they had informed the chief about it, they would have come up with something, some other ideas, and they would have stayed in the market. But what they did was they were so scared to go and tell the chief. That was a huge failure, and hence there was no technological enhancement at all in their mobile software or anything. Okay, and it eventually failed. Okay, the Nokia's OS was symbiosis. You know, you guys remember symbiosis? That's their Nokia's OS. So when every other phone started mapping themselves with Android, okay, Nokia was not able to switch over. That was the main issue. Okay, and Apple had its own software, iOS. Apple had its own iOS OS. It's iOS. Okay, it's OS already. Nokia had symbiosis, but it was not able to shift to Android. That was a huge failure. But now they have developed the technology and they're trying to bounce back. Okay. So this is a SWOT analysis that everybody should remember. Strength, weakness. When you do any kind of process design or anything, you should always remember this. Strength, weakness, opportunity, and threat. What are the strengths of your product? What are the weaknesses of your product? Opportunity. What are the opportunities that are available? And what are the threats in the market? Okay. Who are all your competitors? You have to know. Okay. For example, let's take a simple thing. Okay. Today morning, I just went and bought washing powder. Okay. How many different washing powders are there? Can I name a few washing powders? Ariel, Surf Excel, Tide, Lean, Wheel. Have you heard about Ponmandu? Yes, sir. Ponmandu washing powder is available nowadays. Do you know that? It is Arasan powder is there. But how many of us prefer Ponmandu and Arasan? Tell me. We go only for what? Which brand do we go for? Ariel. Many of us go for Tide because of their advertisement. That orange thing will come, it will swipe on the screen, and what will happen? one white patch will come. Again, did you notice that if the person in that advertisement, if he shakes, is that the particular portion will also move. Have you noticed that during the next time when you watch in just see, only that screen only goes white. Okay, it is not that person's shirt. Actually, the shirt says the same color only. Only the screen is being the brightness of the screen is being increased. You can see from that the graphics thing that is happening there. Alright, so we should know who is our competitor, and then only we have to get into any kind of design analysis or anything. A startup just about how startups have come. This I'm just going to finish it off. Kupatoti.com. Have anyone heard about it? Kupatoti.com.
Yes,
You can go check it out. What these people do is, if you just tell them that you have so much of garbage at home, not regular garbage which is being picked up by corporation, not that garbage, an electronic garbage or any other thing, okay, newspapers or any something that is beyond food, okay. If you want to dispose it, if you just tell them, they will come and collect it and go. You can go check it in the website. Okay, this was where when I was in my college days. So I'm talking about 2004. Okay. So what they basically do is they upload the rate of each material that they're going to buy in there, the rate at which they will buy in their website, daily or weekly basis. Okay. So based on that, you can sell your products to them. They are basically scrap dealers. Okay, these are a bunch of engineers only, I think. I don't remember exactly. Bunch of engineers who have formed this thing. Okay, scrap, there is so much of profit in scrap. How many of you know this? You might think that the person who is collecting scrap, he might look in a very, he might have dressed in a very normal way with a lot of dirt all over him, and he'll be collecting papers, and he'll be collecting from rack pickers and all, okay, beggars. They will come and give all these milk packet covers and all those things, and they will collect it. But there are many people who are so rich and still doing this business. I know a person basically, okay, who's something that I know of. They have built a huge house just dealing only with scraps. Okay, you might think they are just buying it from us for per kg 8 rupees. Let's say newspaper per kg 8 rupees they are buying, but they sell it for 50 rupees per kg to the companies who are in need of paper pulp. Paper pulp manufacturing companies are there now. They will come and collect the paper from these kind of scrap dealers for the cost of 50 rupees per kg. So what is the profit they are looking at? 42 rupees per kg. Just think. In a month, if they are able to deliver 100, okay, 4,200 rupees from just papers. Just think. Okay. I'm not asking you to do all that, just telling how business is being done. Okay. Yes, just like that. Electronic gadget scrap and all also they will collect. That is what happens in kupatoti.com. Okay. Next, how Instagram started. I'll just share the slide with you. You can just have a look at it. As we are running short of time, we have demo. I'll just quickly go through and what it started the crowdfunding project. Can you see the screen? Crowdfunding products we're just having Pebble Times smartwatch. Okay, this was done in Kickstarter.com, the platform Kickstarter, and look at the amount that person has raised. How much money? The goal was only 500,000. Okay, that is $5 lakh or $500,000. But how much money people have invested in this idea? Just see how much. 2 million. $2 million they gave him to make this product come into reality. Just think. And how much time it has come? Just think. 32 days only. In just 32 days, is it 2 million? How much is it? 20 million. 20 million, yeah. $20 million people are invested on this guy's, this person's idea. And this happened in 2015. And how many funding people have done? See, 78,471 people have invested in this guy's business. Understood? Next, look at this flow hive. You must have come across this flow hive. Have you seen it? Have you seen in videos? Flow hive. Where the racks inside the beehive, there will be racks, right? Okay, there will be different racks. Okay. What this flow hive does is, the racks are arranged in such a way that when it is, when a crank, when a mechanism, it has a small mechanism inside. When it is being cranked, okay, if you just give little rotation, what will happen? The hives inside will dislocate itself. The dislocator. When it dislocates, what will happen is the honey inside, which is collected, it will automatically start flowing, and you can collect it with the help of a tap. If possible, I'll just share I'll send you the videos later. Okay. So this is a simple thing. Usually in a hive, what people will do is they will take the hive separately outside. They will chase off all the bees, and they will take the juicy hives, and they will squeeze it and take the honey out of it. Correct? Such a huge process. What these guys have done is, when the bees are inside itself, what they will do, they will just rotate with the help of a crank, and the hives will just move away, and because of that moving away, because of that motion, the honey, the wax, the bees wax will be, it will just squeeze itself automatically, and it will all flow through a tap, and you can just collect the honey outside. Okay, $70,000 was his goal. But look how much he has got. 14 million he has raised. Okay, like this coolest cooler, I just said. Okay, this was also done through funding, but later it was a failure. Okay, look at this jacket, travel jacket. It has so many features. Okay, it has a neck pillow. I'll just read it out for you. Earphone holder, eye mask, drink pocket, passport pocket, microfiber cloth it is, sunglass pocket, and then phone pocket, pen plus stylus, table pocket, tablet pocket, hand warming gloves, that is pockets, blanket pocket, gloves, charger pocket, everything all incorporated inside a travel jacket. So if you wear the jacket, you need not have any kind of hand luggage or anything. Everything will go inside the jacket itself. Okay, this is something that you should be knowing. And this is the joystick by Oya, company called Oya. The goal was $950,000, but they were able to collect 8 million out of it. Okay, so this is something that, these are a lot of things where design plays a huge role. So whenever there's an opportunity, if there's this usual saying, opportunity knocks the door only once. Okay, but nowadays the phrase has been rephrased. Look at this now. If opportunity doesn't knock, what you can do? You have to go build a door directly. Okay, that is how your mentality should be. And then life is too short to be working for someone else's dream. So you can start doing if you have your own ideas and if you have your own design and everything, you can start doing your own things. Okay, own design, own companies. If you have little funds along with you can start your own business. Someone is sitting in the shade today because someone planted a tree a long time ago. Okay, our forefathers, they have invested so much of things in our country, basically. Okay, the previous 60, 40 years before, 60, 70 years before, there's so much of infrastructure that has been built in our country, and because of that only we are flourishing right now. Okay, if that is being demolished, and if there's any kind of thing happening to that, then our future is at risk. Okay, so we should have something, do something for the future as well. Okay, that's what this saying is all about. Okay, so any questions? So thank you all for listening. Any questions that you have regarding this? Anyone? You can just unmute yourself, and I'll have a small demo on Autodesk Fusion 360. Just want to give a glimpse of it, how a prototype is being designed. If there's any questions, I can just answer that, and directly we can go on for another half an hour. I can show you that software. Any questions?
Thank you, Amos, for the wonderful and interesting session. Students, if you have any question, you can interact with Amos sir. Sir, can we have a 2 minutes break, sir? You
Sure,
take
sir.
the break. Then
Sure, sir.
we will start.
Okay, sir. Okay, so we'll have a 2 minutes break, participants, and then we will have the demo directly. Okay.
So after the demonstration, we will share the feedback link. Participants, you have to fill up the feedback link to get your certificate. So it is important.